I appreciate your effort over the last couple of days working with proving triangles congruent. We're going to look at two more types of things in order to prove. Last time we talked about how we could use side, side, side in order to prove triangles congruent. Side, angle, side. We also talked about using hypotenuse leg. Today we're going to add two more, angle, side, angle, and angle, angle, side. Just as two things. What I'm going to expect today for you guys is that you guys are actually participating, that you guys are working hard, that you're going to be able to show me and give me reasons why for things. Today, the book relies heavily on showing flow proofs as a different type of proof. Because it's the first time you'd seen flow proofs, it made easier proofs. I don't particularly like flow proofs. And I'm still trying to get you guys to be good at two-column proofs, so I'm going to have you guys focus on two-column proofs. We'll just do them as two-column proofs. So expect that your proofs will be a little bit easier because they probably expect you to write them as flow proofs. I expect you to write them as two-column proofs. So we're adding two new theorems today. Well, one's a postulate, one's a theorem. Again, I don't really care if you think of them as theorems or postulates. These, the ones that we've talked about in the past, do, but I don't think this really matters a whole lot. For us, angle, side, angle means that side is physically in between. If we label this as an angle here, this is an angle here, we'll see that the side is physically in between. Again, here's the angle, the side is physically in between. The second one, we actually have angle, angle, side. The idea of this is that we have angle down here, and angle down here. The side is actually not in between. Right, again, over here, angles here, angles here. The side is not between those two angles, actually away from it. So it's called the non-included side. They do have to be corresponding. You can't have like one of the S's here and instead maybe have like this side over here. It would have to be the same area, or it has to be the corresponding side. It can't just be some random side somewhere. Okay? So we have any questions about these two postulates? Okay. Okay. This is where you're going to have to start thinking a little bit. State the third congruence that is needed to prove that triangle DEF is congruent to triangle MNO. Okay? And it tells you specifically what theorem or postulate it wants you to use, in this case, side, angle, side. So what I would do is I would just mark these pictures. This is side DE congruent to side MN. It tells us that M is congruent to D. If we want to prove this by side, angle, side, what do we need to prove congruent? Everyone take a minute, look at it. Emily, what do we have?
Segment DEF is congruent to segment MO.
Congruent to MO, so that should be this right here, right there, which is right. Again, we have a side, an angle, and a side. Here's a side, an angle, and a side. That works out perfectly. Okay? So the idea with this is, I think this is really useful because sometimes when you're trying to work with proofs, you're like, well, I think I'm going to use side, angle, side, but I'm not sure what piece I'm going to have to find. What do I have to do next? Okay? For number two, we're saying that FE, which is right here, is congruent to ON, which is right there. We say that F congruent to O. If we want to prove this by angle, angle, side, we need to prove which angle's congruent. Anthony? Angle D is congruent to angle M. What do you guys think of that? Okay, again, here's your angle, and here's some side. Not in between, it's actually away from the non-included angle. That's good. Let me mark the third one really fast. I'll let you guys try this one on your own. That did not work. Okay. Let me mark this nicely. We have DF here, ON. We have F, and we have O. But this time we want to try proving this by angle, side angle, angle, side angle. Which angle are we going to need to prove congruent to which angle? Kenny? Yeah. Again, angle D congruent to angle M. That would look like this. This time, notice that this side is physically in between those two angles. That's how you can differentiate basically between 2 and 3. That was good. Next one. Is it possible to prove that the triangles are congruent? If so, state a postulate or theorem that you would use. Okay? Some of these are going to be yes, some of them are going to be no, and we'll have to talk about specifically what you can use to prove it. Okay? So it looks to me like we have some sort of angle here, we have some side here, we have some side here, some angle here. Is there any other side or angle that we can prove congruent?
Yes.
Yes, which one? Okay, so WL is congruent to itself. Maybe I'll put two little marks there. To be an S. Is there any SSA postulate? Does that exist? No, there's not. So since there is no SSA, or as I wrote yesterday, there's nothing like that. No theorem that says that. We can actually prove these two triangles congruent. You just can't have any random three pieces. They have to be specific ones. Okay, we only have side, 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 angle, side, angle, side, angle, 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 side, and we learned HL yesterday as well. Okay. Number 8 is there. Let's see. We have some angle up here. We have some side over here. Some side here. Some angle. Is there any other angle or side that we can talk about? Oh, sorry. This is an angle.
Wow.
I don't know. That looks more like a hat than anything else. No idea what's going on. Okay, we'll just erase that. That's an angle. Is there anything else that we could talk about? Who we have, Cole?
Did you say those two are congruent because they're vertical angles?
Oh, so you'd say these two angles here, we probably have to name them with 3 letters, right? Like NST or whatever it is, and HSU, something like that, those two angles. And those are, vertical angles, probably with 2 marks. So we'd have some angle here, some angle up here, and some side that's away from it. It's probably angle, side. And you'd say vertical angles congruence theorem is how you prove it. Yes?
Did you say TS is congruent to SU because S is midpoint?
Do we know it's a midpoint? I think we could definitely say S is the midpoint of this segment because of that. But I don't know if we can necessarily say that it's the midpoint of that side. If it told us that, yeah, we can definitely do that. That's really clever. I've never done any of that. That's good. Number 9, there's a right angle, so you should probably think, hey, maybe we're going to use HL. Maybe a quick hint. Sometimes that works, sometimes it doesn't. Let's see, for HL, we have to have a hypotenuse. That looks like my hypotenuse. This is also a right angle, so there's my hypotenuse. Is there any way we can prove one of the legs congruent to one of the other legs? Okay, you really can't. So we have to look at here's an angle, here's a side away from it. Here's angle, here's a side away from it. So again, this one is angle. Okay? So be careful, because sometimes you'll be like, yeah, I got 3 things, I'm good, I'll just move on. But you have to have the right 3 things in order to work on it. And sometimes you'll get 4 or 5 things, and you're like, oh, cool, I have all sorts of information. Yeah?
Couldn't you use angle, side, angle?
Angle, side, angle. Well, in order to do that, you'd have to have the included side when you said angle, side, angle. Let's see.
Or you might.
So is there any way you could prove those 2 sides congruent? I don't see it right offhand. Maybe there isn't a way, but I like the way that Kimberly said, hey, maybe we could use midpoint. They'd have to tell us first. They'd have to probably give us a little bit more information. I like the way you're thinking, though. That would be angle, side, angle if we could prove those 2 congruent. You're right. Okay. This is kind of weird. Number 14, if we're looking at it really fast, it says triangle BEF. Everyone look at triangle BEF. Triangle BEF, and look at triangle BED. This is BEF. This is BED. It says, how would you present it by side, angle, side? All you really do is you list the sides, list the angles. So you basically say that FE is congruent to ED. You'd say that angle probably BF. E is congruent to angle BD, something like that. And then you'd say by the other side, let's see what's the other side. BF is congruent to BD. That's how you prove it by side, angle, side. Okay? So that's what it's looking for. How do you prove it? You prove it and you just list the parts that it works for. Okay?
We don't have the BD is equal to itself.
Right, that would give you by side, 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 you're right. So you could say that this is congruent to itself, but that doesn't really help aid us in the cause of side angle side. So yeah, it's kind of telling you how are you going to prove this congruent. I'm telling you how you're going to do it. Now you tell me what information I need. You gather the right pieces in order to prove it this way. So it's kind of a little bit harder because you don't have the freedom to choose. Okay. The second one, a little bit different. Again.
Yeah, sure.
Yeah. Okay. The second one, it says ADB. ADB is this giant triangle here, like so. We're going to try to compare it to CFB. So it's this triangle over here. I did not draw this very well. If I look at it, if I try taking this apart, we kind of have an angle here. We have an angle here. So they're corresponding angles. Hey, here. We also have an angle here that's kind of hard to see. Here's an angle here, there's an angle here, which are parts of the triangle. So just because they're overlapping, it's kind of hard to see. So we both have both the base angles. Okay? And if we have angle side angle, it means that we need to somehow prove that FC is going to be congruent to AD. Okay? So that's what's kind of weird. What do you think?
Why couldn't we prove BF is equal to BD because of the side proofs?
Well, that would be very clever, so that would be angle, angle, side. Since it's telling us angle, side angle, we need to make sure that we have the side that's in between the angles. Does that make sense? Gary, tell us what's going on.
For to prove AD and F, so
Yep.
to prove AD and FC, you could say that FD equals FD, or just prove FD, and then you add it to both sides.
Yeah. So what he's saying is basically, we know this top line, so these certain things are congruent. Okay? We know this is congruent because it's given to us. We know the second part over here, this part is congruent because, well, the reflexive property of congruence. From there, we can go ahead and by the, we can kind of just say that since they're congruent, they're equal by the definition of congruent segments. At that point, we can take this phrase right here, and we can basically add FD to both sides. So plus FD equals BC plus FD. All I'm doing is I'm adding the exact same thing to both sides. So that's the addition property of equality. And then I can say, well, AF and FD, that's the same thing as just AD. And DC and FD is the same thing as, I don't know, FC. I'm just shortening this up. This is the long segment. This is FC. This is AD. And then I can just say, hey, AD is congruent to FC by the definition of congruent segments again. Oh, this is angle or segment addition. Yeah.
Yeah, I was going to.
Oh, okay.
It's
So, yeah.
because you know the two inside sides that overlap each other are congruent.
Yep.
And you know the angle between them.
Yeah. That's good. I like it. Okay. So those are the steps. I didn't really list. I didn't have room to kind of list this. But that's kind of the process that we go through if we're trying to prove it. It's really similar to number 27 that I just tweeted a minute ago. If anyone needed that, it should be on my Twitter account somewhere. Probably until eternity, I guess. And this is on here as well. So we can definitely check that stuff out. Is that okay? So at this point, we'd have angle, side, angle in order to prove it. Okay. 16 is kind of dumb. Everyone just picture AFB. AFB, it's kind of this outside triangle over here. Picture CDB. CDB is the outside triangle over there. It gives us all the pieces we need to prove by angle, angle, side. Okay? So all we do is we just list them, making sure that we have the right angles from the right sides. Okay? Okay. Let's look at proofs. This is a two-column proof. This is what you guys should be feeling more comfortable with as we go on. We've done several of them. Some of you aren't feeling very comfortable with them. Some of you guys are like, I'm getting better at this. I'm telling you, in this assignment, your proof should be a little bit shorter, probably 4 to 5 steps is probably about where we're going to be. Depends on how you write the given information. And hopefully you're starting to notice some patterns. You're able to glean these things. And hopefully when we're looking for side, you're noticing, oh, I just need to identify all the sides. If we're looking for angle, side, angle, oh, I mean, I need two angles, and hey, that side in between. Hopefully, it gives you more direction when you're trying to solve this. Okay, so let's look at this given information. First, it tells us this piece. This is given for us. So we're looking at this piece and this piece. Then all of a sudden it comes through and says angle UWX and BYZ. So there are these two angles here. How would those two be congruent to each other? Yeah. Yeah, corresponding angles. And that's the postulate. The very first one we learned was postulate. The rest of them, I think, were theorems. Then it goes through, it tells us, again, some more parallel lines, which, again, was given to us. Those are easy ones for us. Then it goes through and says, hey, how is this guy congruent to this guy based on now these parallel lines? How's that related? Yeah, same thing here. So corresponding angles postulate. Sounds good to me. Step 5, it gives us this piece, which, oh, guess what? That's up here. So it's given again. And if you're keeping track of things, I like to kind of keep score here. This is an angle. This is an angle. This is a side. Where's that side located? I sometimes go to the picture to do this. Here's an angle, side, angle. Because of the way it's drawn in the picture, even though this says angle, angle, side, the picture is screaming what? Angle, side, angle. So that's why the right answer here is angle, side, angle. They'll try to trick you this way by giving you information so that you, if you're keeping track of it this way, and sometimes this will be in the wrong order, like angle, angle, side. You need to go to the picture in order to identify, hey, what order is this going to come in? Does that make sense? And you're shaking the head. Oh, yeah. All right. Okay. Let's look at this one. I saw this one recently on a test somewhere. Maybe it's a quiz, I don't know. So this might be a good one to keep track of. We'll just write this down. Statements. Reasons. Good, when you write these, make sure that you have some steps. I don't know how many, I'm just listing 5. That sounds pretty good to me right now. 5 steps. I will say that angle B is congruent to angle D. It's given to us. It's on our picture already. Also, AC is congruent to EC, and that's given to us. If I look at these, this gives me an angle. This gives me a side. So probably what I'm looking at, and if I look at what triangles I'm looking at, maybe this is sometimes important, it's really all I'm looking at is I'm looking at these two small triangles here. They try to trick you by giving you this extra line here, which really just tries to confuse things. So sometimes I either cover it up or I cross it out or I erase it somehow, or I don't draw it if I'm copying out of the book in order to try proving it. So how can we get either another angle or a side?
Vertical angles.
Okay, so name that angle for me and make sure you name it correctly.
The angle ACB.
ACB. Okay, and what's angle ACB congruent to?
DC.
Sure. Sounds good to me. And what was the reason that you said? Vertical angles congruence theorem. Sounds good to me. So basically what that's saying is that this is congruent to this guy right here. Okay, so that gives us, if we're keeping track of score here, it gives us another angle. Now again, just like I said, this listed angle, side angle. Is that enough information, or do we need to find more information? I guess it's enough to prove it. So triangle ABC is congruent to triangle EBC. Is it angle, side angle though?
No.
Yeah, it's angle, angle, side. You go to the picture, here's an angle, here's a side away from it. Here's an angle, here's a side. Not in between them. Yes, sir.
So once you have your 3 letters, even if they aren't in the right order for improving, you're done.
Yes. Yep. Yeah, and you don't know the order. All I do is I'm just keeping track of what do I have. I'm sort of keeping, like, in your backpack you might have books and notebooks and everything else. You just haven't matched them up in the right order for your classes. Sometimes they're in there because they stack nicely this way, but they're not necessarily right next to what you need. So you have to go to the picture to figure out what is it that I need, what is it that I have, what order does it come in there. So even though it's listed this way, that's not what our answer is. Okay, why don't you guys take a minute? Why don't you guys try this next one? I'm going to pause really quickly, so if you're at home listening to this, why don't you guys take a minute and try this proof as well on your own. Okay, as you're looking at this proof, I just wrote down the given information. Probably once you look at step one, once you see step one and you see that there's some parallel lines, probably what you should start doing is you should start trying to think about maybe alternate interior angles. So right here, if we look at this, we have some alternate interior angles. We just have to figure out how to name these correctly. Hopefully that's angle ABD is congruent to angle CDB. And those would be by the alternate interior angles theorem. After that, let's see, we have two angles. Here's an angle and here's an angle. We'll probably need to find some sort of side somewhere. So if I look at this, probably by the reflexive property, we could say something like DD is congruent to BD. And again, if you wrote that as DB, it would make a lot of difference. And again, that's by the reflexive POC. I think we did that hard enough last time. I don't know what that is. Kind of weird. POC. By that time we have enough information, we could actually write this proof line. ABD is congruent to triangle CDB. And we really have to look at the triangle itself. It looks to me like on this thing we have an angle here, we have an angle here, and we do have the side in between. We have an angle here, definitely the side in between. So this becomes angle, side, angle. Could you make it longer? I'm not sure if you can really find a whole lot more information. So really about 5 steps is where you're at. Of course, you could combine steps 1 and 2. Maybe you could have switched steps 3 and 4 around. That's totally fine. I mean, there is some changes and some flex room. I don't think you could prove this by angle, side. I don't think you could prove it by side, angle, side. I just don't think there's enough information to legitimately find some of the other information. Okay? A lot of people ask me questions like that. A couple other things people ask me questions about is like what the assignment is. So the assignment's listed up here. So we're at five ways to prove triangles congruent. That's basically it. There are a few others, some other random ones that deal with right triangles. But really, if you can do these 5, you can basically prove any triangles congruent with enough work. Again, your assignment, it's pretty short again. It's just a couple problems here and there. The last 4 are proofs. They're short proofs. They're around, I think maybe the longest one's maybe 6 steps if I remember. I did it a couple days ago. But it's around 5 or 6 steps. They should be a little bit more comfortable for you. Also, if you were to go out to my website, if I can do this, if you went out to my website really fast, I know this works, it's recording obviously. You can actually go there. If you go over here, this is actually problem 27. I just tweeted that a little while ago. Additionally, I'm going to record this video. I'm actually going to place it on my blog as well. So wherever it says video, there's actually a video, and you can actually click on it. I'll click on it. This one really fast. This is yesterday's video. If you remember, this is what we did yesterday. You can actually go to specific places. I don't know, like here, and there's that long proof number 25 that we talked about. So if you ever need to go to those things are online, and you can definitely check those out. Okay, let me go back to your assignment. If you need to write that down, please do so. If you ever need help, make sure to ask me questions.